Hey gang, howdy from West Virginia. So it is time for Joke of the Day because that is the best part of the day. So are you ready? Here it comes. Yesterday I tried to catch fog, but missed. Fog is missed. Anyways, let's not miss out on our next lesson, which I need to flip my board around. I was completely unprepared for that. Sticking with the idea of rational expressions. Recall that rational does not mean rational, dude. It means a fraction. And so these are going to be complicated fractions that are not just going to have a single number in the numerator, single number in the denominator. They're going to have numbers and variables in the numerator and denominator. But just like regular fractions, we can simplify them, we can multiply them, divide them, we can add and subtract them. So now we're going to take a look at adding and subtracting rational expressions. Now recall that since they are just fractions, the steps for adding and subtracting rational expressions is going to be just like the steps for adding and subtracting regular fractions. So we need to recall, what does it take to add and subtract fractions? Remember, the gang symbol tells us that when we multiply fractions, we cancel on those diagonals, cancel up and down, and we shoot straight across. And then multiplication and division go hand in hand, so that means that dividing fractions means we copy, change, flip, which takes us back to that multiplication. Adding and subtraction fractions, oh yeah, that's the one that has that common denominator. So we need to get a common denominator, and once we get the common denominator, remember we adjust the numerators and then we add those numerators. So before we get into all these steps, let's take a look at a couple of the basic examples, and I'll refer back to those steps just to make sure that everything is solidified. So again, we've got a couple of fractions here that, yes, are complicated, but they are just fractions. So let's think about what it took if we had just basic fractions. Let's say, for instance, a 2/3 plus perhaps a 1/4. If I was to add a 2/3 and a 1/4, we would need to get that common denominator. The smallest number that a 3 and a 4 will go into is a 12. So I'm going to adjust each of these into 12ths. And what that means is I'm going to take this 3 and I'm going to multiply it by 4 to create a denominator of 12. I'm going to take this 4 and multiply it by 3 to create a denominator of 12. So in other words, this LCD idea, I need to take a look at each of these denominators and I need to say, what would I multiply to them to make them look the same? That's the idea that I'm going to use here in order to get that common denominator. So I'm going to look at those denominators and I'm going to say, I can't really tell what's happening here. But if I break this into its factors, then I can look at these denominators and say, what do they each need to make them look alike? This one will not factor at all. So I'm going to leave it alone as a 1 over a minus 1, but this one definitely will factor. And that a squared minus 1 will factor as an a plus 1 and an a minus 1. And so now what I'm going to do is I'm going to look at each of these and I'm going to say, what do they need to make them look alike? Well, notice this one, if I would multiply it by an a plus 1, now my denominators are completely identical, just like we did right here. But recall that with these basic fractions, you know that what you multiply on a denominator, you must multiply on a numerator so that you don't change the value of that fraction. Because a 4 over 4 is really just a 1. And when you multiply by a 1, do you change value? No, not at all. So I don't want to change the value here, only the looks. So when I multiply on a denominator, I need to multiply on that numerator so that 4 times 2 is 8. And what that tells me is 8/12 has the same value as 2/3. And I'm going to do the same thing here. When I multiply on this denominator, I'm going to multiply on this numerator. And 3 times 1 will give me a 3, telling me that 3/12 has the same value as 1/4. Because 3 over 3 is just a 1, and when you multiply by 1, you don't change value. So that's the idea behind what I'm about to do. What I multiplied on this denominator down here, I'm going to multiply on this numerator so that I do not change value. And we did that multiplication here and here, so that's exactly what I'm going to do there. It's just that a plus 1 times 1 is just an a plus 1. But now I've got that common denominator all the way across on both. And so just like with basic fractions, we said once we got those common denominators, Once we adjusted those numerators, now it's time to actually add those fractions. So remember, we're going to add those numerators. 8 plus 3 will give me 11. And what do I do about that denominator? I keep it, because I worked awfully hard to get that common denominator, so I'm going to keep it. And that's what we'll do right here. We will combine this numerator with this numerator because it's addition. A plus 1 plus 2a, well, a plus 2a is 3a. 3a plus 1. And remember, I'm going to keep that denominator because I worked awfully hard to get it. Always simplify a fraction if you can, which would mean I'm going to factor this numerator and see if anything will cancel. But that numerator will not factor. So there's nothing that I can do and I'm stuck. Now, as I've said before, it depends on your instructor, depends on your book as to whether you're allowed to stop here or if you need to go further. Because I've told you many times, old school people like me, we don't keep parentheses in our answers. That's not simplified to us. We would FOIL this thing out. And we would say that an a plus 1 times an a minus 1 is an a squared minus 1. That would be our answer. But it depends on your instructor and your book. Now, let's consider the restriction on the domain on this one. Because remember, I do have fractions. I want to make sure that whatever I'm working with does not create a 0 in the denominator. So I have a denominator here and I have a denominator here. So as I consider that restriction on the domain, I need to consider each of those denominators. The a minus 1 had better not be a 0, and so in that case, the a had better not be a 1, because that will cause a 0 in that denominator. But I need to consider this one as well, the a squared minus 1 equal to 0. Actually, I don't want it to be equal to 0, so I can either factor this, which has been done right here, or I can just add that 1 to both sides. Either way, I'm going to get the same answer. I don't want it to be equal to 0. Here again, this simply means that either this had better not be the 0, in that case, a had better not be a negative 1, or this had better not be a 0, in which case a had better not be a 1. This is a negative 1, that's a positive 1. The positive one's already been mentioned here, so I don't need to mention it again. I just need that one. So, that's not necessarily a basic case because I don't have common denominators, but this is how you will add your rational expressions. Let me flip back to that beginning board where I've got the steps written so that I can reiterate what the steps say. Notice that the steps say that first I need to get those common denominators. I might need to factor to get that LCD. We saw that in that second fraction. That denominator of a squared minus 1, I needed to turn it into an a plus 1 and an a minus 1 to be able to find what that common denominator will be. Then I needed to multiply my numerators and my denominators of each fraction by the factors that were needed to make that LCD. That first fraction of a minus 1, I needed to multiply the denominator by an a plus 1 and the numerator by an a plus 1 to not only create that common denominator, but to adjust those numerators. And then we add or subtract the numerators. We added those numerators and we kept that denominator. Here's the caveat to this that we're about to look at. If we are subtracting, we need to be careful what happens with a subtraction problem. So let me flip the board over and put a new problem up here and show you what happens whenever you subtract. So give me a minute with this, enjoy the scenery, enjoy those little creatures that are out there in this deep cold. All right. So let's get us another example here. This one is a 2x plus 3 divided by 3x minus 6 minus a 3 minus x over 3x minus 6. So here we are subtracting a couple of fractions. Yes, they are complicated fractions, but they are just fractions. So we need to recall again, what does it take to subtract a couple of fractions? Yes, common denominators. The beauty is these already have common denominators, so no adjustments need to be made. But recall that, let's say we had a couple of basic fractions, like let's say we had a 4/5 minus a 3/5, and we have that common denominator. Recall what we do is we subtract the numerators. We say 4 minus 3 will give me a 1, and keep that denominator. So that's the idea here. I'm going to subtract these numerators. I just have to be very careful because I'm not just subtracting a 3, I'm subtracting the entire numerator. Oftentimes what I do to prevent me from making mistakes is I put a parentheses around that numerator to remind me I'm subtracting all of it. So I will say 2x plus 3 over a 3x minus 6, and I'm going to distribute that negative through that parentheses. Now when I distribute the negative through the parentheses, I get a negative 3 plus x, and what happens is that kicks it into an addition problem because I distributed the negative through. That's stuff that we've talked about many, many times before. So now that I've kicked it into an addition problem, I go back to those addition rules that say, oh, common denominator, combine the numerators and keep the denominator. So when I combine the numerators, 2x plus x is a 3x, and then 3 plus a negative 3 cancels out, and recall I'm going to keep that denominator. This time I didn't work awfully hard to get it, but I like that it's a common denominator, so I'm going to keep it. Now recall that you should always simplify a fraction if you can, which means cancel, but I can only cancel factors that are common. Factors are things that are multiplied together. Please be very careful. Don't just cancel out these 3x's. This minus 6 right here has completely messed that up. So I need to factor that denominator in order to find the common factors that will cancel, common multiples that will cancel. So my numerator, I'm going to leave it alone, but my denominator, I can take a 3 out of each one of those, divide it out. 3x divided by 3 is x. 6 divided by 3 is a minus 2. Now that I do have multiplication down here, because it's 3 times parentheses, 3 times parentheses, here's the two things that are being multiplied together. So now I have those factors in the denominator. And now I can say, okay, the 3's will cancel because I have factors, which leaves me with an x over an x minus 2. And yet again, do not cancel those x's because they're not factors at all. This is my answer. And then just remember, I always need to consider that restriction on the domain. I always need to consider what will cause a 0 in that denominator of that fraction. And in this case, I've got two fractions that I need to be concerned about. So I'm going to take a look at the first fraction and say that denominator of 3x minus 6 had better not be a 0. What would cause it to be a 0? Well, let's add that 6, and then let's divide by that 3. Aha, a 2 would cause a 0 in that denominator. And sure enough, 3 times 2 is 6. 6 minus 6 would cause a 0. That fraction would no longer exist. It would be undefined. And then I've got a second fraction, but notice that that denominator is the same thing. I don't need to check it twice. I just need to know that it happens. So my restriction on the domain is going to be x equals, or x better not be a negative 2. And it can be any other number. Positive, negative, fraction, decimal, irrational number, anything. Just not a 2, because that'll cause a 0 in the denominator. Okay, so that was not a super complicated case of subtracting those fractions or subtracting those rational expressions, but I do want to reiterate, get that common denominator. You might need a factor to get it. We didn't have to do that here because we already had common denominators. Multiply those numerators and denominators of each fraction by factors that are needed to create that common denominator. Didn't have to do that because we already had a common denominator. But it says add or subtract the numerators. Here's what we were looking at. If you are subtracting, recall that you're subtracting the entire second numerator. So you need to distribute that negative all the way through. Notice that's in all caps because this is where people mess up. All the way through the second numerator. All the way through. And when you do, it kicks it back into an addition problem. You can combine up those numerators and keep that denominator. So, let's take a look at just a couple more to make sure that we are very good at adding and subtracting our rational expressions. Once again, enjoy that scenery and all the little critters that are out there. I get myself ready for the next example. So we've got a 6x squared plus 17x minus 40 over x squared plus x minus 20. We're going to add a 3 over x minus 4, and we're going to subtract a 5 over x plus 5. Oh my goodness, a lot going on here. But I think we can handle it. I think we're good with this because we know that when we add and subtract fractions, we need common denominators. So we're going to look at all three of these denominators and we're going to say, what do they all need to make them all look alike? that requires that I factor those denominators. Now notice that the 2 in the back, they can't factor. They're done. There's nothing that I can do with them. So I'm going to carry them on down. But this first denominator will factor. Now typically we would factor everywhere that we possibly can. You might be asking, why are you not factoring that numerator? I'll show you in just a minute. You can. It's not wrong. It's just creating more work for yourself than what you need to do. Hang tight with me and I'll show you why. So I'm going to factor this denominator. Notice that there is nothing common that I can divide out, so I'm headed for that double parentheses. This sign in the back tells me I've got opposite signs. One's a plus, one's a minus. I'm going to factor this into the front slots as an x and an x. And now I'm going to split this into the back 2 slots. I want 2 numbers that are going to multiply for 20. They're going to subtract for a 1 because the signs are opposite. That's a 5 and a 4. So I'll put them in there and hope that I've got it right. Check those outsides and insides. Out here I get a negative 5x. In here a positive 4x. That gives me a negative 1x. I have the right number, wrong sign. Remember, right number, wrong sign simply means switch up those signs. Now I've got a positive 5x and negative 4x. That gives me the positive 1x that I wanted. Notice too, typically the other denominators will tell you how this should be factored, because my goal is to get a common denominator, and frequently that will be my clue as to what that common denominator will be. So now I'm going to look at each one of these. I'm going to say, what do they need to make them all look the same? If this one was multiplied by an x plus 5, they would be the same. If this one was multiplied by an x minus 4, they would all be the same. So I'm creating those common denominators all the way across, but when I multiply on a denominator, I have to multiply on a numerator. Recall, because I don't want to change the value of the fraction, only what it looks like. So at this point, what I now have is, I've got my 6x squared plus 17x minus 40 over that common denominator, and here's where I get a little bit sloppy. I generally do not approve of being sloppy, but I know these are the same denominators all the way across, so I tend to do this just to keep my hand from cramping up. So here's my common denominator. I'll bring it back in here later. Plus 3 times x plus 5 over common denominator minus 5 times x minus 4 over common denominator. And recall that once I have those common denominators, I am ready to combine those numerators. It's just the way that these are written here, I can't combine them with anything. Maybe now you're going, oh, that's why she never factored this one. Because if I factored it, I would have to come back to the expanded form anyways. So I'm going to not foil this, but distribute the 3 through here so that I will be able to combine everything up once again over common denominator. Now be very careful here. What exactly am I distributing? A negative 5. So negative 5 times x is negative 5x. Negative 5 times 4 is positive 20 over common denominator. And recall that puts it back into an addition problem. So now I am ready to combine up those numerators. Because everything is expanded, I've got common denominators all the way across, and I have addition problems here. So a 6x squared plus no other 6x squared is going to carry it down. A 17x plus a 3x is 20x. 20x plus a negative 5x is a 15x. And now a negative 40 plus a 15 is a negative 25. A negative 25 plus 20 is a negative 5. All over the common denominator. Now I'm going to bring it back in because I only have to write it once. Recall that I need to simplify my fraction if I can. The only way it'll simplify is if I can find common factors. So I'm going to factor that numerator. Notice that when I factor it, nothing common that will come out, and I'm headed for that double parentheses. Now let's use some reasoning skills here. Remember, this means opposite signs. One's a plus, one's a minus. This will only split up as a 5 and a 1. That's it. In order for anything up here to cancel with anything down here, if it will only split up, if this will only split up as a 5 and a 1, then I need this to be the 5, and I need this to be the x, and this to be the 1. So in other words, the only way for anything to cancel is for this to factor into an x plus 5 And in this case, if I'm going to split this up as an x and, that would have to be a 6x. Because x times 6x is 6x squared. 5 times negative 1 is negative 5. I need to check those outsides and insides to become a 15x. Out here I will get a negative x. In here I'll get a 30x. But a 30x and a negative x is a 29x, not that 15x. So my point is this. It might factor, but there is no way that it will factor in any way that would create anything down here, because certainly this cannot split up as a 4 and anything at all. So it needs to split as a 5 and a 1. That's the only way it splits. That means this has to be an x if it's going to factor correctly, and it won't. So therefore, this is not helpful at all, and I'm stuck here as my answer. And as I've said before, depending on your instructor, depending on your book, my old school self would say I better FOIL that denominator, and I better get an x squared plus x minus 20 on that denominator. But perhaps your book, perhaps your instructor will keep that. Now, let's consider that restriction on the domain. Remember, restriction on the domain, I'm just going to abbreviate it R-O-D, the rod, the restriction on the domain. I'm going to look at all these denominators here. I don't want zeros anywhere. Now this one, I'm going to consider its factored form right here. That x minus 4 had better not be a 0. If that's the case, x had better not be a 4. In addition, the x plus 5 had better not be a 0. If that's the case, x had better not be a negative 5. Consider this one. This x minus 4 had better not be a 0, but I did that already. Consider this one. This x plus 5 had better not be a 0, but I did that already. So here's my restrictions on my domain. X had better not be a 4, x had better not be a negative 5. Anything else is perfectly fine. So hopefully this is really emphasizing for you these steps that I mentioned before for adding and subtracting those rational expressions. Get those common denominators. You might need to factor in order to get that LCD. Once you get that LCD, multiply all the numerators and denominators of each fraction by those factors that we need to create that least common denominator all the way across. And then add or subtract those numerators, but if you're subtracting, distribute that negative all the way through that second parentheses, all the way through what you're subtracting, because you're subtracting the entire numerator, and keep those denominators. So let's look at just a couple more to make sure we are very, very good at these adding and subtracting fractions. What I've noticed over the years is that students get very good at multiplying rational expressions. They get very good at dividing rational expressions. Where we have a breakdown is actually this adding and subtracting. This is where things get a little bit challenging. So I like to do several examples for you to make sure we're very good at this. So I've got a 5 over 2x plus 8 plus a 7 over 3x plus 12. And I want to add those two rational expressions. Remember, to add fractions, I need to get common denominators. So I'm looking at these two, and I need to figure out what they each need to make them look alike. That means I need to factor each one of those denominators to figure out what they need. This denominator, I can take a 2 out. That'll leave me with an x plus 4. This one, I can take a 3 out, and that'll leave me with an x plus 4. So as I look at each of these denominators, I'm going, okay, both of them have an x plus 4, so this one needs a 3, and this one needs a 2. Now all my denominators are the same. So I'm going to multiply this numerator by 3 so that I don't change the value, only the looks. I'm going to multiply this numerator by 2, yet again, so I don't change value, only looks. So that gives me a 15 on this one over my, let's go ahead and say 3 times 2 is 6. And then this one becomes a 14 over, we'll call it 6. And now that I have those common denominators, I am ready to combine up those numerators. So a 15 plus 14 will give me a 29, and it's a 29 over 6 times x plus 4. Yet again, always simplify a fraction if you can. Is there a number that will go into both 29 and 6? No, there isn't, because 29 is prime. So that means I'm left with this. If your instructor in your textbook will take it. If not, old school people, let's go ahead and distribute that through and get a 29 over 6x plus 24. Now, once again, we've got to consider that rod, that restriction on the domain. And I need to consider both of these denominators. In this denominator, the 2x plus 8, honestly, once I look at this, I can just go down to the factored form right here. Because remember, this indicates that these are the two factors together that are being multiplied, and I don't want to get a 0, so one of the two has got to be the 0 if that's going to happen. Well, the 2 can't be a 0. So that means this is the only thing that could be the 0. I could have done this on every one of these, but we're picking it up now. So basically, instead of looking at the 2x plus 8, I'm going to look at its factored form, and I'm going to say, well, that x plus 4, it had better not be a 0. That means that the x had better not be a negative 4. And once again, consider this denominator. Look at its factored form. The 3 can't be a 0 anyway, so this x plus 4 had better not be a 0, which I've already considered. So that is the only restriction on the domain. X can be anything at all, just not a negative 4. Okay, so let's take a look at one last example. Like I said, I just really want us to be very good at this, and I want nothing to surprise us at all. So one more to make us really strong. And in this example, we have an x squared minus 4x over x squared minus x minus 6 minus an x minus 6 over x squared minus x minus 6. Notice here that we are subtracting those fractions, which means we need common denominators. But the beauty is, what are you noticing? Oh yes, half our work is done because we have common denominators. So that means we are ready to just go ahead and subtract. I don't need to adjust any numerators because I have a common denominator. That's the only reason I would adjust numerators, is to create common denominators. So when I've already got them, I'm just going to go ahead and subtract those numerators. I just need to be very careful because remember, I'm subtracting all of this. Sometimes I put a parentheses around it to remind me not just the x, but all of it. So I'm subtracting the x, subtracting the negative 6, which means I'm distributing that negative through. When I do, remember, that turns it into an addition problem. So now then, I have the common denominator. I'm adding them up. So I'm going to combine those numerators. X squared will not combine with anything, so I'm just going to carry it down as an x squared. Negative 4x plus a negative x is a negative 5x. And then that positive 6 will not combine with anything. And I'm going to keep that denominator. I didn't necessarily work really hard to get it, but by all means, I like it, so I'm not going to mess it up. But I need to simplify my fraction if I will. So I'm going to factor that numerator, factor that denominator to see if anything will cancel. So in that numerator, there's nothing that I can divide out of each and every term. Always, 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 always do that first. But this back sign being a plus is going to tell me I have same signs. I need to figure out, are they both positive, both negative? This will tell me what they are. They are both minuses. So I'm going to take this first term, split it into the front slots. I'm going to take this back term, split it into these. So I want two numbers that are going to multiply for 6. They're going to add for a 5 because the signs are the same. That's going to be a 3 and a 2. And sure enough, when I check outsides and insides, I get a negative 2x and a negative 3x. That gives me a negative 5x. Now I'm going to factor that denominator. Once again, nothing common that I can divide out. This back sign tells me I have opposite signs. One's a plus, one's a minus. Split this up into the front slots. I want two numbers that are going to multiply for 6. They're going to subtract for a 1 because these signs are the same. That's still a 3 and a 2, so I'm going to throw them in here and hope I got it right. Out here I got a negative 2x, in here a positive 3x. That gives me a positive x. Oops, I wanted a negative x. But remember, right number, wrong sign is easy to fix. Just change those signs. Now I get a positive 2x and a negative 3x. That gives me that negative x that I wanted. So now everything's factored and I'm ready to cancel in those, not diagonals, but I'm ready to cancel up and down. Both of them have an x minus 3 in common, so it cancels out. And I am simply left with that x minus 2 over x plus 2. Remember, guys, you can only cancel factors. Factors are things that are multiplied together. We have parentheses times parentheses. Parentheses times parentheses. Here's the two things that are being multiplied together. So I can cancel common parentheses. Same thing down here. But here, this is an x minus a 2, an x plus a 2. So I cannot cancel those 2's because they're being subtracted, they're being added. In addition, I cannot cancel the x's. Being subtracted, being added. I can only cancel things that are being multiplied. So I am stuck with this one, and that's as good as it gets. But I do need to consider that restriction on the domain. I need to consider that rod. And so I'm going to take a look at this denominator, and I'm going to say, okay, that x squared minus x minus 6 had better not be a 0. I'm going to look at its factored form because that's the easiest way to go with it. Its factored form is sitting right here. So that x minus 3 had better not be a 0, in which case x had better not be a 3. Or the x plus 2 had better not be a 0, in which case the x had better not be a negative 2. And so there's my restriction on the domain. X can be anything at all, just not a negative 2, not a positive 3. And I hope that helps with adding and subtracting rational expressions. Let me reiterate once again. They are just fractions, guys. Yeah, complicated fractions, but they are just fractions. So therefore, get those common denominators. We just might need to factor to find them. Once we figure out what that common denominator is, we need to make them all look the same. So we're going to multiply those denominators by everything that makes them look the same, but that means we need to multiply the numerators by those same factors that are making them look the same. Once we do that, we can add or subtract those numerators. If we're subtracting, remember, you're subtracting that entire numerator. So distribute that negative all the way through that numerator, and then go ahead and combine things up because now you're adding up those fractions and keep that denominator. And don't forget that restriction on the domain. You don't want a 0 in the denominator. Consider what will make that happen. And your x cannot be any of those. All right, I hope it helps. Have a great day.